Okay, so welcome to my series of short video about load calculation, also called Manual J. Hopefully you've watched one of my previous video, so you know now what the load calculation is, what it does, and how to take advantage of the load calculation to increase the efficiency in your house. But today, what I want to do is I want to compare a house built, the same house built on the 2009 Energy Code and the 2012 Energy Code. So we're just going to change the data based on the code, and we'll see the result, and we'll compare the two and see which one is more efficient and by how much. So let's start with the 2009 energy code. So it's still the same 2900 square foot house I've been using in all my videos. So, but now we're going to use the 2009 energy code requirement for the Dallas-Fort Worth area. So we have vented attic and duct in the attic. So we're in the Dallas-Fort Worth area. So what did the 2009 code require? Well, as far as the floor, there was no specific requirement for this region, so we're still going to use our same concrete slab we've been using all along. So we still have that same concrete slab. Now in the attic, 2009 code require for this region to use R30 of insulation on the attic floor. So here I've got R30 of insulation on the attic floor. Okay. On the wall, 2009 code, we could use 2x4 with R13 of insulation between the stud cavity. No board insulation, brick finish with stud. And then on the windows, the value on the windows for the 2009 code allow us to use aluminum windows again. So it doesn't have to be, but remember we're looking at the minimum requirement for the 2009 code. Okay. So as far as air infiltration, it's the very first time, at least in this region, that air infiltration was specified on the energy code. So for this region, air infiltration for 2009 code is 7 air exchange per hour, which translate that into a load calculation. It's about an average construction. So here I've got average construction. And then for the duct, no specification on the location of the duct, so we're going to put the duct in the attic because that's the way most houses are built. Vented attic, duct in the attic, so that's what we're going to do. So when we look at the load, 2009 specs house, 2900 square foot house, so in the summer, the house is gaining 45,770 BTU of heat is coming inside the house. And then in the winter, the house is losing 65,514 BTU. So what I wanted to check is how does the 2012 house compare to the 2009? So here I've got the same house, but this time I'm going to build a house using 2012 energy code requirement. Again, for the Dallas-Fort Worth area, we still have a vented attic and duct in the attic because, believe it or not, that's allowed on the 2012 code. But I'll go through that a little bit later. So we're still in the Dallas-Fort Worth area. Okay, so what changed? Well, the floor hasn't changed, so we can still use our concrete slab. Now, in the attic, we were at R30 of insulation for 2009. 2012 code require now R38 of insulation on the attic floor. So we've got R38 of insulation on the attic floor with radiant barrier, by the way. Now the wall. So now the 2012 code, we must have 2x6 stud with R19 of insulation. If we're building a house using 2x4, which we still can with 2012 code, we must have R5 of board insulation on top of the R13 of insulation between the stud. But I'm going to use the 2x6 just to keep it simple. And then the window, now this is the new requirement value for the window. You're not going to find aluminum windows with this value, so we got to use vinyl windows. It could be fiberglass, wood windows, or vinyl, but aluminum windows, you're not going to find aluminum windows with this value. So the next step is we're looking at the air infiltration. Now the 2012 code for this region is 3 air exchange per hour. So translate that into the Manual J, that's a tight construction. So 2009 code is 7 air exchange per hour, which is an average construction. 2012 code, it's 3 air exchange per hour, which is a tight construction. But the big sin in the 2012 code, we can still have the duct outside the condition space. And that's the way most houses are still built, with the duct outside the condition space. So here, we're going to put the duct in the attic outside the condition space. Now, what the 2012 code changed a little bit is the insulation around the duct now must be R value of 8 on the supply side, but we can still have 6 on the return side. Okay, so now if we look at our load preview, this is our new 2012 house. So in the summer, the house is gaining 38,584 BTU of heat is entering the house in the summer. And then in the winter, 52,375 BTU of heat is leaving the house in the winter. So now how does that compare to the 2009 house? Well, I've got them side by side. So this is the 2009 specs house. This is the 2012 specs house. So on the 2009 specs house, in the summer, 45,770 BTU of heat is entering the house. 2012, 38,584 BTU is entering the house. So that's about a 7,000 BTU improvement. So the 2012 code is more efficient in the summer by 7,000 BTU. And then in the winter, the 2009 house is losing 65,514 BTU. The 2012 house is losing 52,375 BTU. So the 2012 house is more efficient in the winter, but about 13,000 BTU, which is over a ton. And if you've looked at my video about air infiltration has a lot to do with the heat loss in the winter, much more than the added insulation. So now we've compared a 2012 house to the 2009 house. Now what I want to do next is compare that 2012 house to the retrofit house that we did previously. So if you haven't watched my previous video, previously what I did is I took a 30-year-old house, inefficient house, and we turned this house into a high efficient house by replacing the aluminum windows with vinyl windows, and by moving the duct from outside the conditioned space to inside the conditioned space, or making the attic a conditioned attic. So I want to compare this and see how much better the 2012 is. Okay, so here I've got them side by side. So this is a 2012 house built with 2012 energy code requirement on the top. And then at the bottom, this is a retrofit, 30-year-old retrofit house. If you haven't watched my video, you need to watch it so you'll know how I turn a 30-year-old house into a high-performance house by doing two major retrofit. Basically, we replace the aluminum windows with vinyl windows, and we move the duct from outside the conditioned space to inside the conditioned space. And then we came up with that data by doing those two things. So if we compare the two, so a 2012 house, 38,584 BTU of heat is entering the house in the summer. On the retrofit house, 30-year-old house, 40,076 BTU of heat is entering the house. So that's only a 1,500 BTU difference between the two, which is quite amazing considering, this is an old 30-year-old house that we retrofit. Now if you look in the winter, our 2012 house is losing 52,375 BTU of heat in the winter, and our retrofit house is losing 61,987 BTU of heat. Now you notice here there is quite a difference between the two. And if you haven't watched my video about air infiltration, you need to do so because you'll understand better. But basically, air infiltration has a greater benefit in the winter than it does in the summer. And that's what the 2012 house is taking care of air infiltration. And that's why it's 10,000 BTU more efficient than our older house where we didn't do anything for air infiltration. So anyway, I just want to compare the two to see. But I think if you have an older home, don't desperate. You can make many improvements to your house and improve the efficiency of your house with the help of the load calculation. You never get quite to the 2012 house, but we can still improve the 2012 house. And if you watch my next video, I'm gonna do a video which is 2012 house ducts outside the condition space, which is what this is, compared to having the duct inside the condition space. And now we're really gonna step up our game and do a pretty much a net zero home. So anyway, hopefully you'll see me on that next video. In the meantime, if you need to order your manual J or load calculation, you can go on my website. If you go to the bottom of the page, right here, I've got the information that I need to do a manual J. So thank you again for watching my video, and I hope I will see you in the next video.